So the last contactor we spoke about was this AC contactor, and we saw how it works. And if I have a lamp over here, I have a lamp right there, and I hook up a plug to the grid power, how that will turn on. And if I have a backup UPS and the grid power turns off, right here, how the system will stay on. Okay, this is the changeover contactor. Now I'm going to turn off the UPS. What I want to talk about now is another type of contactor. Make some room, get your view correct. The next contactor I want to talk about is the three-phase. The three-phase contactor, and this is usually used to control motors, induction motors, three-phase motors. But what does it mean to have three phases? I'm going to introduce the concept of three phases very briefly, and maybe in another video we can go into more detail about them. So in the motor, this is my motor, that will turn, and it's going to have three wires coming out of it. Each wire is responsible for a phase. So if I have A, B, and C, A is expecting to receive something like a sine wave. A sine wave. It's expecting to receive this signal. B is also going to be expecting to receive a signal, but it will start at a delay. When we talk about the phase, this is how we denote phase, and it's a shifted angle. So the phase A started like this. Phase B, zoom in a bit. Phase B is going to start at the peak of phase A. So we're going to have something like this. Not entirely accurate because there is a shift. Phase C is going to start at the peak of this or at the end of this. And each of those signals is going to be delivered to a winding inside the motor. If we put them all together, if we add all these phases together, we will get something that looks like this. I'm going to have the first one, and then I'm going to have the second one, and then I'm going to have the third one. So we have, this is a small teaser about three-phase, so we have somewhat of a constant envelope, overall envelope for this. And the frequency of these three phases is about 50 Hertz nominal, 50 to 60 Hertz, but normally 50 Hertz because we have three phases going on. To focus on this angle, the angle that we are talking about over here is how much shift there is between each one. And if I remember correctly, the shift angle is going to be 120 degrees shifted. This is not an entirely accurate representation of what 120 degrees is because they're even more shifted. But it just gives you the idea that they will all start in different places when they come to when the motor receives them. If they were all in the same place, the motor would not move. It would be arrested. They were all like this. If this was our result on each of the coils, the motor wouldn't move. If we had a phase that is missing, the motor would move a little slower. It wouldn't move coherently. So it's important to have three phases. That's why sometimes we have a machine or an instrument that we call three-phase fail protection. We can talk about that later. But now we're going to focus on the contactor. I remember before when we were talking about this contactor, the changeover contactor, how we initially started with a single element of the relay, changing over and we excite a coil. It's the same thing, except in the three-phase contactor, we are also going to have 4 poles. But this one is either normally open or normally closed. We'll talk about that later. And these ones are all connected, are all going to be like this. It's going to be an open switch and they are all mechanically connected and there's a coil that is going to excite it. So when the coil is excited, they all turn down, and when the coil is not excited, they all turn off. And the wires A, B, and C go in here. Just like that. But now there is a little trick to it. If I have a motor, three-phase, if I have a dual-phase motor, it only gives positive and negative. If I have something like this, it is only giving me a positive and a negative. How do I turn it on? There is something that we call a starting capacitor. It's a capacitor, like the one we know, and we connect it between the negative and a third wire that will actually go to the motor. This one helps the motor run. Because when you think of it, when I give the motor the electricity, this is A and this is B. Okay, so this is A. And I'm giving it the electricity. I'm gonna get a sine wave. Okay, there is an inductor inside. There's going to be an inductor inside. And an inductor is one of the components that's responsible for phase shift. So it comes out and it goes through here, goes through the output, and we are going to have a phase shift as a result of the inductor. So how do I introduce a new phase into the motor? By using a capacitor, because capacitors and inductors can both cause a phase shift in the electric signal. So C, which is the line end for a capacitor, it will cause the third phase shift that I'm expecting. So this is how we get the three phase out of here. Then there's also something else that's important. If I switch these two, if I put the negative on one side and the third wire on the other side, the motor will change the direction that it is turning in. If I'm going clockwise, it will go anti-clockwise. So how do we connect this to the contactor? I'm going to redraw an entire setup. So I have my motor, okay, and I'm going to have A, I'm going to have B, and I'm going to have a capacitor, and that's going to be C. And these are going to be my three outputs. I'm going to take my contactor to, I'm only going to put 3, and A will go here, B will go here, and C will go here. Or wait, this is where the power is going to come in. I'm going to have my AC signal, positive and negative, coming through here. And the capacitor that's supposed to be here, instead, I'm going to take it and put it over here. And the output is going to go to A, to B, to C. That's how it will work. This one's going to go to A, this one's going to go to B, this one's going to go to C. Here I have positive, negative, and the running and the starting capacitor. This is a very basic setup. What we have going on with it, I'm going to take the wires that we were using from the changeover contactor to wire this one. We normally use the same electricity that we're going to supply the motor to supply the contactor. It's just to excite the coil and so that it turns on. All the electricity can come from somewhere else. So we take it, wire it up from the two coils. This wire is going to, yes. So if I connect it, I hook it up, we can see that it is conducting and the poles are closed. If I remove it, it's going to release. Okay. Let me get a small motor and a capacitor to see how we hook everything up in this case. Alright, so I've got a few motors. I have this motor and I have a bigger one. This is a 3-phase AC motor. And this is also an AC motor. They're both AC because the way I can tell that they are AC motors is because the stator has coils. It does not have permanent magnets. We can talk about that later. This one also has coils inside the stator and not permanent magnets. And this is what a capacitor that I was talking about looks like. It can handle 450 volts, 3 microfarads, 50 hertz. So here's what we're going to do. I'm going to take the contactor and I'm going to take a jumper because this wire is going to supply the motor with the power. So I'm going to give it, we have A, B, and C. Alright, I'm not going to use this last one because it's not in the application. So I'm going to take this and I'm going to plug it in like that. And this one is going to supply line 1. That's my positive. Okay. The positive will then go through a wire. I'll put it in here. So once these are closed, the power will go from here. Will travel through this wire and we are out of frame. Okay, that's better. Okay, so live, it's gonna go through this wire. This one's gonna close, and this is gonna go through here. It's gonna come out of another wire, assuming it's the blue one. This one will return the current that's traveling through the second pole, and it will leave through the negative. And the negative is going to be this wire. This one, I'm going to take it. Just like that. And I'm going to take it and put it in A. Now we have B. Okay, so let's go over it again. The positive came through the brown wire, the live wire. It went through this, through line 1, which is A, then out, through the red, it went through a coil, and then it came back, and then it went through the blue. The blue gave it back to the negative. So we have only 2 phases that we've completed. Now we can use the capacitor to get the third phase that we need. We're gonna take the third one of the capacitor wires, and I'm gonna connect it from the negative. It will charge the capacitor up, and then the voltage will discharge, and then it will go through and provide a third phase for me to energize the motor. Okay. So it goes through the capacitor, it gets energized, goes, and then it's going to come out and go to the yellow wire. Okay, that's good. And because I also want to demonstrate when we change the direction of the capacitor, how the motor will change direction. Okay, so let's take this. So now let us just go over the connections one more time. The positive is going to go through here. It's going to come out of here into the red. It's going to go through the coil. We are now in delta connection. We are in the delta connection. Let me draw the circuit over here as well. So we have the positive AC. It is going in, and it's going to go to a coil. Out from another coil, and then it's going to go through the negative AC, which is then going to send another one to the third coil, and then back out. So it's like these two are connected to one another, and these two return to complete the cycle. So we have a delta phase, a delta configuration. Let's plug it in and see what goes on. Will anything blow up? Okay, let's turn it on, and we are moving. Okay, say I lost a phase. Okay, we have live. Say I lost the yellow phase. I'm gonna disconnect this. You can hear it goes a bit slower. Here, listen. If I connect it, I'm not sure if you can hear it, but the phase does change. The speed changes a bit because it lost a phase, but it's still able to